All right. Good morning, everyone. So welcome back to another round of Steel Connect webinar, where I'm your host today, and Rocky, and I'll be talking about steel and building related topics. All right. So before we start, as usual, if you have any questions to ask during this webinar, feel free to drop your questions in the Q&A box on the side. So the one on the right is demonstrating if, let's say, you are joining us via your mobile phone, this is how you can actually join us and ask the questions. All right. So for fellows architects and engineers, if you wish to submit your LAM CPD points or BM CPD hours, then you can stay through the entire webinar. And I'll share the QR code at the end of the slide, where you can fill up a survey form, also as well as submitting your LAM or BM membership number, okay, via the survey form. All right. So without further ado, let's start today's topic. Okay, so today's topic is about GI or GL. So debunking the popular beliefs amid tropical weather. So before I go on to defining what are GI and GL, of course these are common terms within our industry. But before that, let me just explain to you why this topic arises and why is it important for us to discuss, and also tell you about what are the differences. So for example, if let's say you are a first-time home buyer, right, or you are really designing and also budgeting for a huge project that you want reliability. Okay, so it'd be super frustrating if, let's say, you found out the roof started rusting only within, say, 10 years of the building operation. Okay, or even buying into a house and then to find out that it starts rusting or leaking after 10 years. So those would be very, very frustrating. But those are not things that are not happening nowadays, but in fact it is happening due to the nature, right? Nature wears off the building material and cause it to start rusting. All right, these are some of the examples. If you go to Google Map, you can find examples where roof becomes brownish within a certain number of years, and most often it is not ideal for especially homeowners, because they would need to go through trouble to actually determine where are the leakage, and most often homeowners are not able to identify, pinpoint where are the locations that cause, or rather what is the source of leakage. Right. So in a way, those owners or building owners, especially for homeowners as well as large warehouses, they will need to actually budget in extra costs to do maintenance, right? Or there are costs that are normally unseen. For example, if let's say there's a factory that needs to be replaced with the roof needs to be replaced for a new one, then there'll be a downtime for the factory. So those are opportunity costs that are unseen during the designing stage, or when you are doing specification, right? Or in a much more macro sense, there could be economical impact. In what sense is, imagine we want the economy to build things, right? But fixing things would be something that is less than ideal. So we want to reduce things that we need to fix, so that the economy can be much more productive, right? So we build it once and then let it last for a longer period of time. So that is our philosophy. And of course, in the market, there are always a dilemma on choosing a cheaper material or a more expensive material, and those are dilemmas that I believe most of you architects, engineers would face, right? So whether to choose product A or product B. So that can root in many can be from many factors, but one of them would be on material choices, right? And to factor that in our Malaysia tropical weather, we have conditions like humid air and frequent rain, right? So these could accelerate the reaction of those metals, right? So aside from that, also there are conditions like hot sunny days, right, which could wear off certain components of the building, right? Or because it's hot, so it could accelerate the reaction. So if you are familiar with chemistry, heat is one of the catalysts that could accelerate reaction. So hot sunny day could also be a factor to accelerate the reaction of a metal. Okay, so of course there are still a lot of popular beliefs despite the wide range of informations that are out there, right? That galvanized coating will not rust, right? So period. So what it means is that most often when people ask for, okay, I want a good product, right? That lasts long. When you tell them, okay, it's a galvanized coating and it will not rust. So the thing that I'll cringe on is not rust. So it is not really not rust, but rather how long does it take to rust, right? So there are spectrums, right? Those that are long lasting and those that are not so long lasting, meaning it still lasts, but then lasts for maybe 1 year or lasts for 2 years, right? So those needs to be set in context rather than saying it would not rust, right? So not rusting for how long? So do not take the word galvanized coating for granted. Okay, because there are a lot of factors which I will explain later that would affect how the coating perform. Okay, so of course another common problem that we also hear people face is that they always hear that there are tests that are done, right, by a reputable tester, right, or reputable lab, right, but whether the tests that are followed are realistic enough, right? And we actually covered this in our previous webinar, which you can actually go back to have a look last month, where we talk about discrepancies of performance tests. So the two examples here are actually this product of the same spec, meaning essentially the same product. And it was placed in two different types of tests. One is what we call salt spray test, right? Another one is outdoor exposure test. So of course, over here you want the product to be realistic. But in this case, right, the salt spray test does not reflect its true performance that are seen at the outdoor. Okay, so this is another one. Sometimes those tests give you misleading results. So here there's another spec of product that is showing worse results at the bottom, the green color one. But if you compare both outdoor results of the beige color one and the green color one, it seems like it's the performance in actual is in reverse. So in this case, we have already debunked which are the realistic tests that you should ask for, and which are the tests that you should not rely too much upon too much on when you're making decisions. Okay, so the message here is that you need is really paramount for you to identify material suitability for your environment, right? So I'm sure there are the audience, they are not only in Malaysia but other part of the world. So but today I'll just focus on tropical weather, but you can of course take into consideration of what are the variation in your environment, right? So material suitability, right? So later on I'll explain what are suitable and what are not suitable. So when it comes to galvanized steel, right, so it's basically steel core, and then there are some sort of coating on both sides. That's what we call galvanized coating, right, or galvanized steel. So if you go back to the galvanic series, which also I previously explained, galvanic series will give you an indicator which are the metals that are relatively more active than the others when paired together, right, in this galvanic cell, right? So there are if you look at the table, carbon steel and the one below carbon steel, or more skewed towards the anodic side are the metals that are more active, right? And you can see there are only a few choices here: cadmium, aluminium, zinc, magnesium, and so on, right? So these are the metals that can be cladded or so-called coated onto steel to form so-called galvanized steel, right? But of course, there are established companies or established technology that are widely in use in the market, right? So the first one is, one of the most common one that you can see also on structure, on decking and so on. Is called galvanized zinc, 99% zinc coating, right? So there's another one also very common for cladding is 55% aluminum and 43.5% zinc. So these are the different variation in terms of the coating composition, right? You can use different metals to form together become what we call alloy, right? So that different composition is very important as part of the coating. And this difference coating leads me to definition of GI and GL. So what are GI and GL, right? So what are these two terms for, right? So to start with, just now you actually have seen a brief glimpse of what the definition, which are the common coatings, right? But in practical terms, there are actually different types of coating, and it's also controlled by different standards, right? Established national standards. So here are examples of Australian standards and Malaysian standards that defines GI and GL, right? So GI and GL are common terms. If you search Google, you will definitely find the definition, right? So all these standards, right, it will actually define, okay, the coating composition of GI and GL, right? So I'll be going on the composition shortly. So other than that, the standards itself would determine how to actually control the quality, which you definitely can go back to my previous webinar to revisit this topic, right? Which we explained what are the type of tests that are done within these standards, right? So GI, right, is actually an abbreviation for galvanized iron, right? Or common term, we call them galvanized steel, galvanized iron. Essentially, is referring to the same thing. All right. So what it means is that on top of the steel, right, there are 99% of zinc coated, right, on both sides. Okay. So of course, with pair of it with less than 1% of what we call minor addition of control elements, right? So these are elements to perhaps improve adhesion of the coating and so on. Right, that is GI, and GL is actually a trademark brand, but it's widely used. It's called galvalume. All right, so it is a term that refers to coating that on top of steel that are composed of 50 to 60% aluminum, right, or 40 to 50% zinc. Of course, the trademark term galvalume has a very, very specific coating composition, as I've shown earlier. Is 55% aluminum, 43.5% zinc. And of course, there are some minor compositions of such as 1 to 2% of silicon, and again some minor addition of control elements. So those are GI and GL. And when you zoom into the coating, right, aside from just now the diagram, this is how it looks like, right? GI, essentially you have a homogeneous layer of zinc, okay? But for GL, you have essentially a mixture of zinc and aluminum, right? So it's like marbling effect, right? So where you have some gaps where it's filled with zinc, and then most of it with aluminum. Okay, so of course, when it comes to comparing these two, of course, these two are still widely used, in the same type of product, right? For example, roofing, cladding. Okay, so now the question is that which one is more suitable. Remember, we talk about suitability of the material for cladding, right? So before we go into suitability and concluding which one is more suitable, let's just tackle an issue here, right? When you classify GI and GL, it is still not very specific, because there are actually many types of thicknesses, right? So 10 kg of rice is different from 5 kg of rice, right? But it's still rice, right? But just one will last you longer than the other one, right? So same thing over here. GI and GL are just a generic term describing these two different types of galvanic coating or galvanic coated steel. But there are different coating thicknesses, right? So most often people again would take it for granted and just say, oh, just keep it galvanized steel, would not rust on, right? So without any further context. So here, let me just give you a specific context. If you are to compare GI and GL, right? Should you compare Z150 and AZ150? So the abbreviation here, Z means GI, which is having 99% zinc, and then AZ means aluminum and zinc with this specific percentage as described in SGL. And the number behind actually represents coating mass, right? So maybe I'm not sure whether audience you guys are familiar with this gram per square meter or coating mass, but let me just attempt to explain it in more common seen items. For example, have you seen a package paper? I'm sure if let's say you're working in an office or you went to a so-called stationery shop, you definitely see package paper, right? And on the paper packaging, you can see the term GSM or G gram per square m is 2, right? Those are the same term, right? Same definition. Those are coating mass or so-called paper mass, right? So how do they define it, right? Is that you had to measure the sample, right? 1 meter square, right? And within this 1 meter square, for example, if let's say I take Z150, right? So this 1 meter square sample of steel, there'll be coatings on both sides, right? Remember the galvanic coating? So the coating itself, if you remove it and you measure the coating alone, it should make up 150 grams, right? So dividing that, of course, do some calculation. The coating on 1 meter square of sample, right, of Z150 galvanized steel. So what that would give you? 150 grams per meter square of zinc coating, right? So that's how we define Z150, right? Of course, vice versa for AZ150, you have 1 meter square of the coated steel sample, and then you remove the coating and you measure the weight difference. So that gives you, the reading AZ150, Z150, or maybe there are more. So those are the classification that are again specified in the standards, right? How can you classify one product as one standard, and how to go about controlling it? All right. So just now I mentioned a question: should we compare Z150 and AZ150, right? So because the coating mass is the same, or should we compare by coating thickness, right? What I mean by here is that you measure you compare the coating that has similar thickness of zinc coating and aluminum zinc coating, right? So why do we want to compare coating thickness or so-called coating that has the same thickness, right? Is because if let's say you have experience, measuring samples on site and doing quality, for example, you will actually understand what I mean, right? Because when you go on site, you are just relying on a paper to define whether the product is up to the specification, up to what you bought, right? Or you refer to measuring the thickness, right? So of course, if let's say the steel itself is in say one of the common one, 0.42 mm, then your measurement of the the final product would not be 0.42 because it will add on the metallic coating as well, so-called the zinc and aluminum zinc coating, right? As pointed out in the red arrow, right? So that is one of the practical reasons, right, why you want to measure, why you want to compare, similar thicknesses. And later on, I'll also share, the comparisons in terms of performance as well, right? But in order for us to determine the coating thicknesses, right, of different alloy, of course, we have to refer back to the standards, because in the standards there are certain, data that defines or what are the density of the zinc or aluminum zinc alloy, right? So of course here some are actually retrieved from the standards, some are actually found in a general knowledge repository. Like aluminum is actually depending on different alloy, the density of aluminum is around 2,700 kilograms per meter cube, right? So you compare that to zinc, which has a density of 7,140 kilograms per meter cube. So within the same volume, actually, zinc is much more denser, right? So in a way, you need more material for the same thickness, right? That's how you can see it. So if you compare that to steel, steel is even more dense, right? That's why steel is harder, okay, in this sense. All right, so we use this density information, and then we calculate the coating, thickness. So over here, these are retrieved from the respective standard I shown you earlier. Density for zinc coating is actually 7,140, and then the combination of aluminum and zinc in such ratio, 55% and 43.5, will give you a density of around 3,680 kilograms per meter cube. So using this data that are published from all these standards, right? So we can actually compare, what are the coating thickness of Z150 and AZ150. And based on those comparison, what you can see is that, this is a formula, again, derived from the standard. So the coating thickness can be derived from the coating mass, which are shown on the, the number at the back of the abbreviation, right? The coating Z150. So it means 150. Then you multiply it by 100, right? 1,000, and divide it by the density in kilograms per meter cube, right? So this will give you a thickness in mm. Okay, so for example, Z150, then you came the number and also the density, you give you 0.021 mm. All right. If you want to just change it to another term called micron, some layperson, they normally use this term, then it will be 21 micron. You divide it by 1,000, it will be 21 micron, right? So AZ150, right, you calculate based on this density, right? It will give you 0.041 mm, right? So of course, some of you who are familiar and have heard, seen me reference this to AZ150 to 0.05 or 0.05, yeah. It is referencing to different standards because there are many different standards, and when we say AZ150 equals to 0.05 mm, it's referencing to Australian standards. Okay, but in terms of density calculation, I just want you to be aware. This is, how it looks like, right? The reading. Okay, and over here, Z150 is actually half the thickness of AZ150. So meaning, if let's say you measure it of the same coated steel, Z150 will give you thinner. So this would actually create some concern in terms of, okay, if you measure it on site, right? So it'll be way thinner. So people would be like, oh, is this not a good quality product? No, it's just different specs. Yeah, it's just different specs. Yeah. So so that's why the reason why we want to compare, this in terms of coating, so-called the coating class Z150 and AZ150, is to tell you that it is not in the same physical thickness. All right. So how about if let's say we compare it to similar coating thickness, then one of the common one is Z275, which are we still can find it in the market. So upon calculation, Z275 compute out to be 0.038. Right. So if you compare that to AZ150, it comes around the same thickness, right? 0.038, 0.041. Okay. So comparing these two and also Z150. So what are the performance, right? So in the end, that is what is important, right? You want to know how long this GI and GL in this specific coating class can last, right? So of course, it leads us to the next point, right? Performance of GI and GL. Okay. Unfortunately, if you refer back to the standards that I highlighted earlier, the standards only does quality tests, meaning they only tell you, okay, if let's say you want to produce AZ150 coated steel, how should you control it? But they will never tell you how can you classify this AZ150 as very long lasting or not so long lasting. I mean, those are can be classified, right, based on different types of tests, right? So in all these standards, mostly they are only covering quality tests, meaning how consistent is the product coming out from the factory, right? But afraid not, we have actually done the studies, and of course it's very, very conclusive, and you can even find it yourself online as well, right? So before I give you the results, let me just share with you what are the corrosion mechanisms of GI and GL, so that you can basically visualize and understand why is it that GI and GL will have different duration of lifespan. Okay, so let's start with GI, because the coating itself is quite homogeneous. It's a layer of zinc, right, on top of steel, right? Of course, the diagram here only show one side. Yeah, of course there is another side of it, which I just crop it. Otherwise, it would just be too minute to look into, to zoom into this coating, right, to look at how it performs. All right. So corrosion mechanism of a GI works somewhat like this. So if it's exposed to the weather, like oxygen, water, and so on, those are the common elements in nature, right? Wherever you go, it's just varying in degrees. And for water, of course, we know it's more commonly seen in tropical weather, where almost every day we get rain, right? If we don't get rain, we get humid hot air, right? I mean, essentially it's just humid. But also we get dry days, right? Strong sunny days that are super dry. So there are a cycle. So based on this cycle, the zinc coating that or the galvanic coating of zinc that protects the steel will actually form what we call zinc oxide, right? So zinc oxide will be formed, right? And upon exposure to water or to carbon dioxide, then it will form zinc hydroxide or zinc carbonate, right? So these are the two possible composition of zinc byproduct when it's corroded. So these two, of course, zinc hydroxide actually is soluble, right? Zinc carbonate, however, is not so soluble, right? So ideally, you want it to stay on top. But both, if let's say you change the rainwater to slightly acidic or slightly alkaline, then it will dissolve again, right? So based on this cycle of wetting and drying and wetting and drying, okay, the coating itself will wear off soon, right? So the mechanism is that it will just wear off because it's a homogeneous layer, right? So it will just wear off consistently. I mean, provided the coating is even lah. Okay, so once it's wear off in this cyclical atmospheric weather, then once it's completely depleted, what you get is just the bare steel, and then that steel itself will start rusting. Okay, so that is how you get to the end of the coating lifespan, right? So you first spot the rust, right, when the coating is gone. Okay, so that is GI's corrosion mechanism. How about GL, right? Mixture of aluminum and zinc. Okay, so here actually the so-called the zinc itself, right, will actually start depleting first, right? So you start depleting, and then there'll be so-called the same type of composition form, which is zinc hydroxide or zinc carbonate, whichever, right, depending on what it's exposed to. And once it's depleted, right, just like GI, right, for GL you have still this layer of aluminum, which from this microstructure, it seems like there are some porosity once the zinc is gone, but then the aluminum itself will still provide what we call galvanic protection to steel, right? So once it's corroded, right, then the aluminum will form aluminum oxide or aluminum hydroxide, right? Again, depending on environment. Then you start depleting and depleting and depleting, and eventually rust will form, right? So those are the two different mechanisms, right? So if we were to compare in terms of corrosion rate, how will it differ, right? So based on our studies, of course, this is how it would, I mean, just to interpret it in a much more graphical sense, right? Is that GI would normally wear off faster, right, in this kind of cyclical manner, right? Because it's just a homogeneous layer of zinc coating, right? And of course, like I mentioned, the problem now is not really identifying which one is wears off faster and not. It's rather what kind of test is considered reliable, right? So what kind of performance test rather. And we have seen publications still circulated in the market. Again, new publication. Yeah. I mean, when I say publication, it means like brochures and information that are posted by different companies that are still relying on salt spray to tell you, okay, this is the performance, right? Remember, I keep highlighting the word cyclical, right? So it has to do with outdoor, right? So that's why instead of doing tests that are done inside the lab that are not cyclical, we should start looking at outdoor exposure tests to give us a more reliable result. Okay, because outdoor exposure or outdoor test itself, in the tropical weather, right, you get a higher humidity, a cyclical weather where some days is hotter and drier, and some locations even it will give you some more corrosive environment due to the salinity, right? Salt that are airborne or that are laden in the air. Okay, so aside from that, also nowadays, because almost everywhere you go, right, there'll be factories unless you go to those outside of town, outside of industrial area, outside of civilization per se. Otherwise, there are certain level of all these contaminants, when there's rain, right? That could be acid rain, depending on where you are, and those rain composition would definitely react with GI and GL. Okay, and again, based on outdoor tests and also different locations, we did compare GI and GL, and we did compare different type of coating in terms of coating mass and all that. So these are some of the results, just to put it in perspective. So this is actually an exposure near the sea for 6 years, right? And what you can see is that GI Z275, as what I calculated earlier, right? The coating is actually very similar in thickness to AZ150. That is why most of our comparison does of these two, right? Just to give you an idea, right? GI and GL, this is how it looks like after 6 years. And after 12 years of the same location, this is how it will look like, right? You get rusty or you don't get rusty, right? But bear in mind, the AZ150, there are corrosion happening. It's just that it's the corrosion of zinc or corrosion of aluminium. But the whole gist of it is that steel, the steel that is in the core, STEEL, that is in the core, has not been rusted yet. That is very, very important because that is the one that provides all the structural integrity of your roof, that provides support when people go on top to do maintenance. And nowadays, very popular maintenance of solar panels, right? So those are the things that are important to keep the steel in better integrity, right? And of course, again, another example, also near the sea for 5 years, right? What you can see here is Z275 again, rusting started from the side. But what I want to caution you is that, remember earlier, we posed a question whether to compare Z150 and AZ150. Well, this is how it looks like. So we don't really have a result of Z150 in visual, but we have a Z180, which is thicker in coating thickness. And this is how it looks like, right? If you were to compare it to Z180, it'll be even worse because the thinner it is, remember, I make a reference to the rice, 10 kg and 5 kg. So the coating is lesser than it is for Z275. So if this is the case, right, then the coating will last even shorter period, right? So of course we can compare, different kind of coating class, but at the end of the day, what we want to tell you is that it depends on suitability of these two, GI and GL. Where are they used and where are they most suitable for? Otherwise, you have a material that is less efficient in that environment or in that application. Okay. So of course, there'll be another question, right? How about we paint it over? What will be the reaction? Okay. Remember, I shared with you the comparison of two different samples, the beige color and the green color. The beige color is actually PPGI, right? The green color is PPGR, and these are the outdoor tests. And based on this, it's quite straightforward. The paint itself can only do so much in protecting the galvanic coating. But at the end of the day, it depends on what kind of substrate, a GI or GL that you are using, right? I take one studies, right, just to share with you. We do a lot of studies on site rather than in the lab to get more feedbacks from customers as well as observing how different building material, coated steel in particular, performs in different environments. Right, and one of those that I can relate to this is one project, one area where there are two buildings. They are using PPGI and PPGL. Right, so both installed within the same, I would say 5 to 10 years. I'll give you a number later, but these are the results. Yeah. So first one is actually this one. If you can see the name, is called Adventure Inc. Is around 540 meters away from the sea. Right. Just for your context, this is not in Malaysia. This is in South Africa. And the building itself uses, the roof uses a PPGI, right? And after 8.5 years, this is how it looks like. I wouldn't dwell on it. I wouldn't comment too much. So no corrosion, no sign of rusts, right? That's important. But of course, there are some limitations over here because the clip that was that it used was GI actually. So that was one of the reasons why we came here, because the clip was rusted and the customer was concerned, right? What is going on, right? So if the clip rusted, then the roof will not be attaching well onto the structure. So sooner or later, especially this kind of weather, there'll be gusts of wind and there could be a safety concern. So this is of course PVGL looks great, no sign of corrosion after 8.5 years, but the clip had issue. And we walk not too far away, and this other building is actually around 800 meters away from the same sea, right? And it was actually installed 5 years from its lifespan, and this is how it looks like, because the contractor was actually replacing the roof because of this, right? So what you can see from here is that the PVGI actually started rusting all across the edges, and this will create concern also. I mean, aside from leaking, downtime for the factory. It's a small scale factory, yeah. It also affect the maintenance, right? The owner needs to put more cost to replace and to pay for the workers, and we all know how expensive are workers nowadays, right? So what we saw was consistently all the cut edges actually started showing rusts, and yeah, so it's quite sad, and also the clip that's made of GI actually also rusted. So this one is worse because you can see actually the clip itself already you can use your hand and just pull it apart. So it essentially lost its mechanical strength, or rather connection. So yeah, so that's how GI would perform in that context. Yeah. So what I'm trying to say is that GI is not very suitable if, let's say, you put it in a cyclical environment like our tropical environment. Okay, but of course, having said that, there are places where GI is suitable, right? And there are places where GI is not suitable, or GL is suitable and not suitable, right? It leads me to the last point, right? Limitation of GI and GL. So of course, these you have to really consider your options here, and what are the limitations, or is the limitation so huge that you can only use it for so little application, right? So those are the consideration, or if let's say for another material, would it have better or less limitation, right? So those are the consideration you need to take into consideration. You need to take into account when you're choosing these kind of materials, right? Although it does not look much different, or maybe it costs slightly more, right? There are consequences that you don't see when the building is just completed, and you'll be like, it looks nice, but you would not want to recognize it to yourself if, let's say, within maybe 5 years or 10 years, within 10 years down the road, you'd be like, oh, this is an eyesore, the roof is not in good shape, the structure might not be in good shape. So you need to make that judgment call. I'm giving you the information, and then you make the judgment call. All right, so limitations. So as I have presented and stressed on, GI is it will wear faster, put it that way. It will wear actually faster in the outdoor cyclical environment, and this is actually an external source that actually put different galvanic coating in different ratio, as you can see here. The one on the right is representing AZ, and then they actually did a slight variation in terms of the aluminum content, and there are like 4%, 7% aluminum content over here, right? Aside from AZ and also ZAC, right? So what you can see from here is this. if let's say the building, the building material of GI and GL is, again, these are very specific, Z275 and AZ150, but I'll refer to them as GI and GL. Okay, so GI and GL, if you put it near the sea, in what we call severe marine environment, GI will have 4 years before you see first sign of rust, right? GL in the same environment, 15 years before you see the first sign of rust. And if you move it slightly further, of course, the duration or the lifespan to first time sign of rust will be longer. So for GI, it's 16 years. For GL, more than 25 years. When they concluded this experiment, they have not even seen sign of rust yet. Okay, so if they move out to rural area, right, then GI 14 years, right? GL again more than 25 years. They have not even seen a sign of rust at that. For the experiment. All right. So all in all is to say that GL will wear faster when you put it in the outdoor environment, and especially for tropical, like I mentioned, the cycle of wetness and dryness, and we are actually a developing country, right, in Malaysia. So there bound to be industries, factories nearby that could affect these wearing cycles. Okay, so you need to make a judgment call on what type of product that you need to use, and of course you need to emphasize what is the coating type, GI or GL, and also what is the coating class. We call them coating class. AZ what, right? AZ 150, AZ 100, AZ 200. What are the coating class that you are looking for? Of course, there are available products that are out there, so you can always seek for more clarification. And when you do your specification, make sure it's clear, right? Do not just put down. I do still see this quite generically written, where the project will just say, okay, metal decking. Okay, so that is a very dangerous way of specifying, because you have whole range of prices being quoted to you, and then you have no way of justifying why you should choose the more expensive one. If let's say your contract document is so generic, right? So that is a limitation of GI. Of course, when it comes to GL, it's not it will not does all wonders, right? There are limitations. So what you can see from this graph is that is actually the x-axis is the pH range from 0 to 14 and 16. I don't even know 16 exists in the environment. And the y-axis is what we call mass loss, right? The coating reaction rate or wearing rate. And the red color that I highlighted here is actually a GI, right? So what you can see is that within the range of 2 to 14, the reaction rate is actually quite slow. Okay, so for GL, as highlighted in this blue line, right, it will wear faster in a more alkaline environment, and more particularly, alkaline means around the pH, beyond the pH of 7. So what you can see from here is that the reaction will pick up after pH of 12. Okay, so here is to say that if let's say the environment itself is very alkaline, right, or not acidic, alkaline, okay, with the pH of 12 to 14, then GI will be more suitable. So you might ask, okay, what kind of scenario would the environment have such pH, right? So I don't know what kind of industry where within the factory it will have such high pH, because again, it's quite a hazardous environment. But there are situations like permanent formwork where some kind of cement that because cement, as I understood it, has carry a level of alkalinity in it. So typically GL would not be suitable in this kind of environment. So that's why for permanent formwork, GI is still the widely used material, right? And it is rightly so, because it's much more suitable. for that application. Okay, so aside from that, of course, if you have seen or know of any industry that emits or create an environment that is around pH of 12 to 14, please do let me know, because I'm interested to find out. Okay, so with that, I'd like to conclude today's topic of GI and GL. Okay, debunking the myth, right? So the first one is defining what is GI and GL, right? When I say defining, it's not just about the coating composition. It's also about the coating thicknesses, right? You want GI, Z150, Z180, or Z275. I mean, those are your call, right? What I presented are the facts, for you to make a better decision. GL also the same. Is that what? Is that 150? If you look back at my previous webinar, you might see, in some standards or in some country, they might even produce AZ50, okay, or AZ70. So those are thinner coating that need not necessarily be longer lasting. So make your judgment, right? So the second one is performance difference in tropical weather, right? So as we are entering into the monsoon season, more people will be faced with roof leakages, that maybe is right below their bed, right? For houses or for factory, it might be right below the crucial area where it should not have any water, right? I can list an example of fertilizer factory. If there is roof leakage, then the yield of the fertilizer will be gone, because the fertilizer was be pelleted and then exposed to water, and it will just dissolve and go into the drainage, right? So those are the scenarios where roof leakage could affect the wellness and also the efficiency of the factory or the dwellers. So be sure you make the right judgment call. See which one is suitable for your environment. Of course, we are always open to discussion and always open to exploring your environment and learn more together about your environment. Okay, and last but not least is the limitation of GI and GL. We cannot just talk about all wonders and without looking at the downside, and also what are the limitations for GI and GL. Which one is more suitable and which one is not so suitable for the same application, right? So those are the things that I have presented. So I hope it gives you an insight and also makes your decision making much more easier in near future. And I hope you learned something today. Of course, now we are right around the end of the year, and we are actually opening up more slots for next year, and planning for next year for more ideas to be shared back to the crowd, right? Architects, engineers, the professionals, right? They are here. So if you have any idea you want to share, say for example your design, your research, feel free to just email us at events@goodescope.com, and we'll have a conversation with you how we can actually deliver the topic to benefit the public, the professionals, right, and also the industry. Okay, so with that, I would like to conclude today's sorry, before we go in, actually let's go into the Q&A first. If anyone has any Q&A, let me see. Yeah, we missed that out. Anyway, okay, so from Miss Surveyor Ng. So all right, so the question is thickness will be different between Z150 and AZ150. Then we are not comparing apple to apple. Yeah, I guess this is a statement. So yes, you are right. We are not comparing apple to apple if let's say it's Z150 and AZ150. And so as you know, sometimes when you go on site, it's very hard for you to determine the specs, especially it's so-called finalized form, right? And these are coatings that are so thin, it's very hard for you to determine. And by measuring the thickness, it does not give you much input of what is the coating. So that's why, I mean, if let's say you measure, one thickness that is like 0.44 compared to one that is like 0.47, then it will actually shock you. So in a way, we want to make sure that it is consistent, consistently compared. So yeah. So hope you learn something from here. So from Colin, is it fair to compare rust between galvanized, meaning red rust, and galvanum black rust, black stains without resin coat? In short, is black stain considered a rust or a water stain? Thanks. All right. So Colin, actually, yeah, some people they would misunderstand the term rust and say corrosion or stains, right? So if you have seen I mean, steel rusting is red color, right? So that's why we call them red rust. So it's actually steel rusting, meaning steel corrosion, right? So that means that there is no galvanized layer on top anymore. So if let's say zinc were to rust, it will be what we call white rust, because it will be zinc oxide or zinc hydroxide is also white color. Zinc carbonate is also white color. So you see some sort of white color. Aluminium, it depends. Sometimes it could be white, sometimes, but most of the time it could be black color. That's why corrosion of aluminium sometimes will give you some darkening. That's why we call them black stains or black rust. Okay, so but rust is actually a very generic term. Normally, technically, we call them corrosion, right? Corrosion means whether the metal itself it gets eroded and whether the material itself reacts to the environment and make it thinner and thinner. That's what we call corrosion. Rust is a very, very lay person's reference, and rust normally refers to steel rusting. And when you want to describe it in color, it'll be red rust, right? And white rust or black rust or black stains, as you call it. So yeah, hope that answer your question. You can't in short, you can't compare red rust and black stains or white rust because they are in a different stage of their lifespan. Remember, just like I explained, zinc corroding, then it will give you zinc hydroxide, zinc carbonate, and so on. So those will be when you see white color rust, right, or white powder. Those are white rust. Okay, so once it's done, then you see red rust. Okay, Feng Chin Dong. So why using 7180 to calculate both is 150 and ASAP? Should use different density, right? Yeah, you're right. It should be using different density. Just now I saw the mistake. So yeah, for AZ 150, it should be using 3680. But you should get a number that is around 0.042, 0.041, sorry. Okay, for AZ 150. All right, thanks for paying attention on that and pointing that out. Okay, Joakim, so which would you recommend between PBGI and PGL in use in fertilizer production or locations where ammonia concentration is high? All right, so it's actually a good question because in a fertilizer production factory, right, I've seen quite a few, but I have not really measured the pH level of those environments. All right, but having said that, ammonia concentration, I'm not sure, if you go up to the roof and then you measure the pH level, how high would it be or how low would it be? But what I do know is that if your environment is corrosive like fertilizer factories, there's no questions that both of these PBGI and PBGL would not last very, very long. I would say in the spectrum of maybe 2 years or maybe 5 years. It depends on luck, really. It depends on the design and how those fertilizer get airborne and all that. So a lot of factors are in play. But if we were to compare PBGI and PBGL, virtually you might find it hard to differentiate. And what we can see is that, if let's say coming from the external, if let's say internal, you have taken care of it by means of, say, shielding it off, or maybe filtering the fertilizer dust, which I have not seen a really proper design for that. Then it comes back to the question of external, right? How corrosive is the external environment? And based on this kind of industrial area, you might see rust starting at 5 years, and so on, right, within that time span. And that is why, if let's say you were to compare these two, externally, I would say PBGL would be much more longer lasting. But if let's say to factor in those exposure to the fertilizer, I dare not give you an answer. Okay, so which would you recommend between okay, same question, but for lime or cement plant? I have not seen too many cement plants or lime production, but based on the one that I've seen, dry cement tend not to be so corrosive unless it is in contact with water. I've seen one that I think the term is called clankers, meaning when it's in dried solid form. It did not react with any of these. I mean the PBG is actually PBGI, I think. PBGL or PBGI, I forgot. And I think the risk is still low for cement and lime, right? Unless they get in contact with water, and yeah. So really, I don't really have a lot of insights on this yet. But definitely, if you have some projects where we can actually visit and study, that would be great. So, Ling, is there any standard that mentions the requirements on the outdoor exposure tests? Yeah, outdoor exposure tests there are, but again, those are from different nationals standards lah. I think Australian standards, they specify in the pre-painted also called PBGL standard, which is AS NZX 2728. Actually, I've covered that in the previous Still Connect webinar, so definitely go back and have a look. And yeah, there are requirements that actually this one I didn't really show it in the previous seminar. So you can actually buy the document, and then inside they also mention briefly the outdoor exposure test. Surveyor, what's the cost difference between PBGI and PBGL in terms of cost per meter square? Surveyor, I'm sorry to disappoint. I don't have the number on top of my head. But definitely we can link you to our sales so that you get the code for PBGI, because we only produce PBGL in its specific brands. So yeah, so yeah, I'll give you the contact after this. So okay, so Joachim, what about performance comparison between a Galvalume, Galfan, ZAM, and Galvaloy, or different coating classes? Is it claimed by some mills that the higher zinc performs better for cut edge? Yeah. So regarding the cut edge performance, right? So you are comparing Galvalume, Galfan. So these are coating with different aluminum concentration, also called aluminum, and there's magnesium and so on. I don't have it with me right now, but I can tell you, if let's say you're saying that the cut edge would perform better, it depends on the context of duration. Let me just flashback just now. So in this environment, just now I mentioned, I have shown this case study, right? The cut edge performance of zinc coated steel, or so-called GI, might be good in a short span, but in the long run, the zinc will wear off faster, so leaving your cut edge vulnerable to all this kind of weathering. So that is where you get corrosion coming from the cut edges. Of course, on the short term, it makes sense, right? To say that, but then we are not looking at short term. I mean, you are not installing your roof for 2-3 years, or in this case, for 5 years, and then you expect to change it every 5 years. I mean, it would take a lot of cost to do that. So that is why we are looking at long term, and in the long term perspective, GL seems to do the job just fine. Right, based on all our studies, GL seems to do the job just fine, be it near the sea, be it in a moderate environment, or be it in urban area, be it in tropical weather. So yeah, it depends on duration, I would say. But long-term wise, GL seems to be doing just fine compared to GI. Hold on. Okay, how to identify the material is GI or GL if it's painted? And how do we know that the material that we specify or purchase is what we are getting? For example, Z275 but not Z180. Okay, so of course this requires, I'll say it depends on different supplier. Some supplier for the same painted product, I mean based on my observation of the market, it would have a range of coating classes, ranging from Z275 all the way to Z80 even. So you need to really, make sure that they specify in the mail cert upon delivery. So you make sure you keep that, so that if let's say there's any quality issue in the future, then you have this hard proof to actually claim that, right? And of course, I think nowadays they are pushed to make sure that there are traceability on the building material itself. So that would even help the traceability and also to trace back what are the specification of the product, so that the producers are accountable. So definitely keep all the documents upon delivery and make sure that you know which one is for which product jack that you are using. All right. So are there differences between Jowlum produced by different mills for the same coating designation? Yeah, Joachim, you are actually pointing out a really good question. So when we refer to Jowlum, so this is actually a licensed technology, where there are only there are quite a lot of licensed producers out there in the market, throughout the world. But there are also unlicensed producer. So the difference between licensed and unlicensed producer of these Jowlum, so-called specific coating class, specific coating composition of 55% aluminum and 43.5% zinc, is that unlicensed one is not, does not have the know-how per se, and sometimes even they might throw in the same ingredient, but then the results come out might not be what we want for Jowlum. And of course, if let's say those licensed producer across, so it depends on their own quality control. So of course, I can say for our company is that we do have annual audits internally to make sure that the coating does not deviate from what it was intended for in that microstructure. So yeah, so it depends on mill to mill, but once it's licensed, then it's safer compared to unlicensed one. But again, it depends on how each of them do their own quality and control, as well as product improvement. So yeah, so and again, Jowlum is just the coating technology, but on top of that, you can have different types of say for example resin, different type of finishes and all that. So those are also one of the differentiating factors. Okay, so will white rust or blackening happen on GL? Yes. Simple answer is yes, because you have zinc also. So reaction of zinc could give you white rust. And again, I mentioned aluminum sometimes could react to give you some white byproduct. But blackening is mostly on aluminium lah. So what would be your recommendation for building that are near sea, say less than 10 meters? Oh, yeah. I mean, yeah. If you compare this distance that is 500 meters and 800 meters away, it gives you this kind of result in 5 years, right? So for PBGI, so my recommendation is GL because it will be much more suitable on the long run. Okay, so it gives you a better bang for your buck within the time span that normal people will expect lah. No people will expect within 5 years to replace the roof. So yeah. Okay, so is there any more questions? If not, then let me just go back again. Just to remind anyone who are interested to submit your ideas and things that you want to talk about, share with us on to our crowd. Then feel free to email us at events@booscope.com and we'll actually get to you. All right. So if there are no more questions, then I would like to conclude today's Steel Connect webinar. And for architects and engineers who would like to submit your membership number, please scan the QR code over here so that you can fill out a survey form and submit your membership number. And for those audience who are, I know that we have consistent audience here. So if you like to improve, help us improve on our Steel Connect webinar, you may also fill in the survey forms so that we can get your feedback, right, on how did we do on this Steel Connect webinar, and then what are the topics that you would like to hear from us in the future. All right, so with that, thank you for joining, and I'll see you next month. Right, bye-bye.